Hello and welcome to the development update from the TAO team. This is the October update, and you're here with me, Fola. And without further ado, I'm going to pass it over to Karim for his overview of the development team's progress this month.
Thank you, Fola, and welcome everyone to the development team update for the month of October. I will give you a brief overview as usual, and then each one of the team members will go into details about their progress. So on the Agoras Live side, Andre, preparing for the release, did some major refactoring of the backend with an eye on scalability and making Agoras Live backend more cloud friendly. And in doing so, he managed to improve the performance of the backend by about 20%. He's also working on creating the test plan for the Agoras Live application as we prepare to hire some testers to do some thorough testing of the entire application. And just as a minor improvement, he removed reliance or the need for logging in very early on to the Agoras Live website, allowing people to browse freely the application before they commit to creating an account. So on the TML development side, Luca continued working on his 2CNF extraction project. He did manage to implement 2CNF extractions from PDDs, which in itself is no small feat. And right now he's working on continuing the integration of the 2CNF within the rest of the BDD library with an eye on making it transparent blend between BDD and 2CNF, which should avoid the BDD exponential explosions. In doing so, he also refactored some of the storage implementation, gone from using maps, STL maps to STL vectors. Ran into a small problem with garbage collection, but we helped him with that. So yeah, he's made some great progress on the 2CNF extraction. Murisi, as usual, has outdone himself again this month. He actually found some performance bottlenecks in the TML core library and managed to improve performance by an amazing 40 times for some programs and about 37% for many other programs by removing some memory allocation bottlenecks. He also finished working on the variable shifters transformation, which also helps with the memory savings within BDDs as well. And in doing so, he had to make sure that he doesn't break canonicity. So that was a tricky thing, but well done, Murisi, again on those performance improvements. Tomasz continued his work on the state block transformation, which is really a usability features for TML. It makes TML a lot easier to use, allowing programmers to control the flow of the program a little better. And in doing so, also he made sure that it interacts well with other transformations such as nested programs. But yeah, that is tricky. Tomasz is also responsible for the IDE, which is currently the best way to access TML. For those of you who are familiar with the old TML playground, I think from now on we're going to be using the TML IDE instead. I strongly encourage you to play with that if you haven't already. Juan continued his work on the arithmetic built-ins, such as the count operators and the basic arithmetic operators. He's also helped test the bit universe or conversion to bit universe transformations that Umar has worked on for a long time. So he helped testing with that. I think that's it for the overview. I'll pass it to the team members to give you some more details.
All right, thank you very much, Karim. Really appreciate it. I'll pass it over to Professor Christoph Benzmuller for his update this month.
Thank you very much. Yeah, there are again 3 lines of activities. The first one is the academic panels, where in the last month, I would say we shifted our attention, in addition to the usual discussions, also to a reflection over the development process of tau, the intended ones for the evolution process, and also try to mutually challenge our current proposals to find out whether we have any limits and aspects that we haven't sufficiently addressed yet. This process is ongoing. My particular interest is in particular in the reflection of how expressive an initial tau language should be, the proposal we make, and whether we have a clear methodology to transition in the evolution process, which is not part of, let's say, the first implementations, but which should be eventually discussed because there might be constraints imposed by the evolution methodology imposed on the first shot for a tau language. So this is an interesting and very stimulating academically inspired discussion, and we continue to learn a lot there. Then in order to foster a discussion in next week, I haven't presented that yet. I have been working on and work out of a simple example that could guide this methodological discussion, namely starting from a very small, idealized little tau language to a more elaborate one, which we could eventually discuss in the next week, how something like that is intended to work out in the long run. Then in addition, as listeners here know, I'm working on this external reasoner that I shared now with colleagues last month on GitHub and gave demos about it. There are little examples we work with. I've mentioned that before. In the last month, I in particular focused on how to deal with, fix some issues and about the dealing with free variables on Tableau branches in the model finding process, where I still had an issue to solve. Now the interest will be to check this model finding performance and team-proving performance of that implementation also for other benchmark examples, and to eventually find out whether there are further problems to be addressed. That's it. I think that's covering the main aspects of the work last month. Yeah.
Brilliant. Thank you very much, Professor Benzmuller. I'll now pass it over to Dr. Kramer for his update and overview this month.
Yes. So I think that Professor Benzmuller already gave a good overview over what we did in this month in the academic panel. I would maybe just sketch a few things to maybe give a bit more insight into the discussions we are having there. So, for example, we have this idea that originates from OHAD that given any particular language that gives us the means to express the things that we need for the everyday usage of tau, we want to have on top of that a richer language that additionally allows us to speak, for example, about consistency of expressions in this language. This is required for discussions about changes to the system, when you want to make sure that when you change the system, that it's still, well, generally, first of all, that it stays consistent, internally coherent, but also you may want to require that changes that are more significant changes to the previous version, so that's somehow inconsistent with some core of the previous version that you want to be rather stable, that those are more difficult maybe to do, for example, that you really need a much higher consensus for these kind of changes than for other changes that just are more like just change some details of the system without really touching the core. But for that, you also need to have this notion of consistency with the core functionality of the system whenever you consider a change. And for these consistency notions, so OHAD has proposed a certain methodology based on Boolean algebras to basically generally add this kind of consistency. Well, to any given language that we might have at any specific time for expressing what we really want to do in everyday business, to on top of that have also a language, a more expressive language that can express this consistency. And we've discussed about the pros and cons of that particular proposal by Ohad, and also an alternative proposal put forward by Christoph and myself that involves the methodology of higher order logic that makes things, let's say, computationally more challenging, but also has less limitations on the side of the expressivity. So we really need to find a good balance between expressivity and computational cost, which is not always easy to find a good balance, but that's why we have to really think hard of what precisely are the use cases that we need, and in which context we really need to compute which things and so on, to get the right balance here, and which of these different proposals we will actually implement in the Tau system.
Thank you very much, Dr. Kramer. I'll now pass it on to Juan for his update this month.
So as Karim already put into advance, I shift the focus for last several weeks from second order logic towards our arithmetic capabilities. In particular, I solved really all lasting issues with our count built-in, which effectively should allow us to implement cardinality constraints in our formulas and in our rules. So I've been digging deep there and fixing issues on the count built-in and extending the possibilities for the actual TML programmer. And this work is on top of what Tomasz did many months ago around the refactoring of our built-in features. And on that aspect of our system, I'm also integrating what Umar has been working with the bit universe transform in order to complete it with the arithmetic primitives or operator for addition and multiplication, and also for inequalities in the sense of less than equal. So these are relevant and promising developments on the TML core to really improve its Boolean algebraic capabilities and yeah, very likely have improved performances on many different use cases. I will point out a last comment regarding some questions both on our Telegram channel and on the monthly questionnaire. The second order logic is still for internal usage. We are still solving some relevant points there that are not ready for general or for end user testing. So we will ask you a little bit more patience. I mentioned we reached to a decent milestone, but we still need to figure out how to deal with the correlations between the let's say first order structures implied by the second order variables. So there are points to deeply consider, but yeah, it's still on the design table, and we will be iterating over them in the short term for sure. So that's all from my side, Fola, and thank you.
Thanks very much, Juan. And I'll now pass it over to Luca for his update this month.
Thank you, Fola. and hello everyone. So this month I managed to finish the first phase of the 2CNF extraction feature, and by this we mean that we are now in a position to extract the 2CNF while the BDD is built, and as a second aspect to have the correct interaction between the BDD storage and the 2CNF storage. As Karim pointed out already, this was quite a challenging task to achieve. We did now, and in the further progress, it is planned that the storage of the 2CNFs is reviewed so that we have the best possible performance with this new feature. And once this is in place, we'll get to the performance improvements of the TML language itself. And the second feature I've been, or not feature, but a second project I've been starting this month is looking into dependency type programming languages, because the new language for the Tau eventually will maybe go in a functional direction. And for this reason, we want to early understand how side effects are treated in dependency type programming language. And I've started my journey in AGDA, which is a dependency type programming language. And yeah, that's what I've been up to this month. Thank you for listening. And I'll give it back to Fola.
Thank you very much, Luca. I'll now pass it over to Andre for his update this month.
Hello, everyone. Last month, I finished, as I told you, I finished all basic functions of our Agoras platform, and was searching for some professional help with the testing of the platform. And while searching for such people, I came to the absolutely needed demand of the proper documentation. Everyone is requesting, especially Swagger documentation for the platform. So I had to put aside everything and start writing this documentation for the backend. And along the way, I did a massive code cleanup and code refactoring, especially on the backend side of the platform. As you can see, this is, for example, how the Swagger documentation looks like. It allows a tester to see what to send, what to expect in return. Also, along the way, I moved our backend to some faster backend framework. It's more than 20% faster. Technically speaking, I moved from Node.js Express to Fastify. Also, I removed all obstacles to run our backend as a stateless service. It will allow us to quickly deploy our backend to services like Heroku or Amazon Lambda in nearest months, and it will allow us to quickly scale horizontally to any demand, any load. Next month, I plan to finish finally this Swagger documentation, get ourselves a proper tester, and that's it. Thank you, everyone. Have a great day.
Thank you very much, Andre. I'll now pass it on to Tomasz for his update this month.
Thank you. Hello, everyone. I've been working on state blocks. Let me show you what is it and how it works. State blocks are helpful for better structuring of a program which is going through many states. And they are especially useful when you have a state you need to visit repeatedly. State blocks are implemented as a transformation which adds a state guard term into bodies of everything inside the block. So, for example, these facts are added only when there is a init fact in the database. These rules, these are executed only when this state run, this term for this state exist in the database. And it does just the transformation that it adds the term into the body of the rule. This way, this rule is executed only when the state is active. If there is this deletion sign after the label of the state, it is a so-called flipping state. This sign adds a new rule into the program saying that when program enters into this state, then it removes the state term from database. So it gets transformed into something, or not something, but into exactly this, which means if there is a finished fact in a database, remove finished fact from the database. And this makes this state to last only one step. This particular program contains 3 state blocks: init, run, and finish. Here program says to enter the init state. And in the init state we add input data, which is a graph represented by a relation E, and we move on to a state called run. And then the program executes these 2 transitive closure rules and it runs until it reaches a fixed point. And this would normally mean the end of the whole program, but what if we want to do more stuff when rules in some state reach a fixed point? And there is a command line option called fixed point step. It is -fp-step or just -fp. This gives the programmer a chance to detect a fixed point. With this command line option enabled, if a program reaches a fixed point, it adds a term $_fp_ into a database and runs one more step of the program. And this way programmer can create a rule which is executed when the program reaches a fixed point. You can see in this rule, when this happens, this fixed point happens, program removes run term and adds finish term into a database. And it also removes the fixed point constant. And then this cleaning rule is executed, so only TC relation is contained in the database at the end. This program gets transformed into something like this. So, of course, you can write states in this TML way, but when you need to write more complex state machines, then it starts to be very difficult to read. Let's see program executed. You can see the programs are identical. Here is another example of a program using state blocks. This program sorts data in relation A, and you can see you can nest states, but it comes with more complex state transitioning. So let's see how it works. And in output we have this print ordering of A finished, and you can see that the original A is ordered here. The first argument here is the order of the data. So you can see this is the first, second, row. And here is the last example. It's an algorithm for solving Sudoku game. So this way we enter all the noun positions. Here's some initialization. And here is the backtracking algorithm. You can see state check, state checked, state failed, next P, next N, recount. These are states we are going through many times, and this way we go through all the game positions and we try all possible values, and anytime we find invalid path we go back and try next number from the row. So this is the last example, so let's see it executed. And here you can see the final solution of the Sudoku game. So that's all from me this month.
Thank you very much, Tomasz. I'll pass it on to Murisi now for his update this month.
Thank you, Fala. So this month I was mainly working on improving performance and memory usage. So one of the things which I did was extend the variable shifter caching mechanism so that we can essentially avoid doing certain kinds of computations when we can identify that they've kind of already been done in the past. So now that's done, and this may improve certain kinds of workloads. I know that certainly there are theoretical gains, but I guess we still need to kind of identify the workloads where this optimization performs the best in. Another thing which I worked on was identifying performance bugs in the binary decision diagram implementation. And essentially by just fixing the core binary decision diagram implementation, I was able to attain a 43 times improvement for some TML programs and less, and still some pretty good performance improvements in other TML programs as well, but maybe not as much as 43 times. So yeah, just a mixture of performance improvements. And this was these bugs were mainly to do with memorization of the results of previous computations, because the core library was kind of forgetting the results of certain computations. It caused the number of computations to exponentially kind of explode, which caused a huge kind of performance drag. So by fixing that, I was able to indirectly improve the performance of TML programs. I also managed to kind of remove some other bottlenecks which were taking linear time. And I also managed to kind of improve the way the engine factorizes certain kinds of computations in order to improve performance. Another thing which I did was now that I'd improved some of these issues in the binary decision diagram library, some other issues, some second order issues started to crop up, in particular issues to do with memory allocation. Memory allocation began to take the most amount of time in TML program execution. And I saw that, if you replace the sophisticated memory allocation mechanisms with just a simple bump allocator, which just kind of just stupidly or dumbly takes a little bit of memory from the operating system, the performance of TML programs also greatly improves. Some programs are improving by 37%. And yeah, so I'm hoping that next month I will flesh out this optimization more, and I will make it such that it integrates better with the TML code base, so that we can all enjoy faster performing TML interpreter. Thanks.
Thank you very much, Murisi. And last but not least, let's pass it on to Ahad for his update on the development during October.
Mostly everything has been said. I've been involved in everything or almost everything you heard here. Just one thing that was not mentioned is the parse tree construction from the early parser, which I wrote. So I put some thought into the various options of how to build a parse forest, and I also transferred this code and research to the team, specifically to Umar and Murisi, to see how they can take it further. And that's all.
All right, thank you very much, Ahad, and thank you to the rest of the team, and thank you to the community for tuning in every month. And yeah, we appreciate all your questions that come in the Q&A. Please continue to send Q&A questions, even though this isn't the Q&A call. Please do continue to send Q&A questions. We'll also put a link in the description to the TML IDE, which is also known as the TML Playground. So when you hear both of those terms, just know that they're the exact same thing. So that will be in the description of the video. So yeah, that's it from us. We'll see you in Telegram, and we look forward to your questions. Thanks again. Cheers.